Ever wondered how many ways you can pick a team of 3 from a group of 10 people? The answer lies hidden in a beautiful pattern called Pascal's triangle. It starts with a 1, and each new number is just the sum of the 2 directly above it. As it grows, this simple triangle reveals the magic of combinations, showing you exactly how many ways you can choose things. This is all powered by something called the binomial coefficient, which looks a bit scary at first glance, but is just a neat formula to calculate any entry in the triangle without drawing the whole thing. It's the secret code behind probability, computer science, and so much more. From picking lottery numbers to arranging your playlist, this elegant piece of math is everywhere. Want to dive deeper into how this works? Hit subscribe and let's explore more amazing math together. Ever seen a math equation so beautiful it almost looks like art? What you're looking at is a fascinating identity involving something called central binomial coefficients. If that sounds complicated, don't worry. Think of Pascal's triangle. The central binomial coefficient is just the biggest number right in the middle of any even-numbered row. A look at this equation. It claims that you can pick 3 of these special numbers, multiply them together, and get the exact same result as multiplying 3 completely different ones. Finding sets of numbers that actually work is a super tough puzzle. For a long time, only a few examples were known, but this slide reveals an entire family of solutions, a hidden pattern that generates countless correct answers. It's a beautiful piece of modern number theory that shows just how deep the rabbit hole of mathematics can go. Thanks for watching, and don't forget to subscribe for more math mysteries. Ever stare at an algebra problem and just see a bunch of meaningless letters and numbers? What if I told you that every equation is actually a secret story, a visual adventure waiting to unfold? Forget dry, boring textbooks. We're talking about turning abstract concepts into living, breathing animations. Imagine an equation like y equals mx plus b. That's not just a formula, it's the blueprint for a journey. The m tells you how steep your path is, and the b shows you exactly where your adventure begins. We can transform these variables into colorful graphs and dynamic shapes, making the whole process feel more like a game than a chore. Suddenly, solving for x becomes a quest to find a hidden treasure on a map. This is how we make math click. If you're ready to see math in a whole new light, hit that subscribe button and join the visual revolution. Thanks for watching. Ever wondered about the numbers hiding right in the middle of Pascal's triangle? These are called central binomial coefficients, and they pop up in the coolest places, like counting the number of ways you can walk back to where you started on a grid. But here's the wild part. These numbers get enormous, incredibly fast. We're talking about numbers so big that if you tried to calculate them, your calculator wouldn't just give you an error. It would probably send you a therapy bill. This is the kind of beautifully weird math that creators like Matt Parker get excited about. Honestly, he's a huge inspiration for this video. What's the most mind-bending math fact you know? Let me know in the comments below. And don't forget to subscribe for more fun with numbers. Thanks for watching. Have you ever seen an equation so beautiful it feels like magic? Today, we're diving into some hidden math magic that will blow your mind, talking about infinite binomial identities. First, let's start with the mystery. What happens when you add up an infinite series of numbers in a very specific pattern? The answer is shockingly simple and elegant. It looks impossible, but it's true. Next, we'll move on to the derivation. Forget boring textbook proofs. I'm going to show you visually, step by step, how we can uncover this amazing result. We'll use colors and animations to make it crystal clear. Finally, we'll put it all together for the infinite proof. You will see with your own eyes why this mathematical magic works forever and ever. Ready to have your mind blown? Let's get started. Make sure to subscribe for more math adventures. Ever wondered how you could lift something 10 times your weight with just one finger? It's not magic, it's physics. And it all comes down to a super simple, beautifully balanced idea. Imagine a seesaw. On this side, in blue, we have your force and your distance from the center. Now, on the other side, in red, we have the heavy object and its distance. The secret sauce is making these two sides equal. A perfect balance shown in glorious green. So you, way out on the end of the lever, can push with a tiny force. And because the big heavy thing is super close to the middle, your little push can lift it like it's nothing. It's how you can lift a car with a jack. Or how an ant could theoretically lift an elephant if it had a long enough stick. Physics is wild, right? Stay curious, and I'll see you in the next one. What if I told you this simple pattern of numbers holds secrets to probability, algebra, and so much more? This is Pascal's triangle. It looks simple enough. You start with a 1 at the top, and each number below is just the sum of the two numbers directly above it. See, 1 plus 2 gives us 3. Easy. But here's where it gets amazing. These numbers tell you the number of ways to choose things. For example, if I flip a coin 3 times, how many different ways can I get exactly one head? Let's check the triangle, row 3, and the answer is 3. It's all right here. This pattern, known as binomial coefficients, shows up everywhere in mathematics and nature. We're just scratching the surface of what this incredible triangle can do. If you love discovering the hidden beauty in math, hit that subscribe button. Thanks for watching. Ever wonder how to make complex ideas look simple and beautiful in your videos? Let's talk about the visual tools that can make your content shine. For those pro-level math animations, like the ones you see on 3 Blue 1 Brown, check out a tool called Manim. For more general animations, Adobe After Effects is fantastic. But don't underestimate the power of a well-animated PowerPoint slide. Need to explain a process? Create crystal clear flowcharts with free tools like Draw, I/O, or Lucidchart, and overlay them on your video. To show software or a calculation in action, OBS Studio is a free and powerful screen recorder. And finally, make abstract concepts stick with analogies. Compare a problem to a family tree or balancing a chemical equation. You can find great stock footage and images on sites like Pexels to bring these ideas to life. Give these tools a try and watch your engagement soar. Thanks for watching, and subscribe for more tips. Ever heard of Diophantine equations? Finding their whole number answers can feel like searching for a needle in a cosmic haystack. If we were to plot all possible solutions on a giant grid, they would appear as just a few rare, scattered points in a vast sea of nothingness. So, how do we find these elusive points? Believe it or not, a key is hidden inside the simple beauty of Pascal's triangle. As we watch this famous pattern unfold into infinity, we realize this isn't just a classroom trick. It's a window into the deep, hidden structures of math itself. These structures are the secret sauce behind powerful computer algorithms, brain-bending puzzles, and the kind of curiosity that pushes science forward. Now it's your turn. What happens if you try this with your own starting values? Share any cool patterns you discover in the comments below. Thanks for watching, and stay curious. Ever see a wild math equation and wonder, does that actually work in the real world? Let's put one to the test right now. We'll start small. Just plug in the number 2. I'll pull up a calculator on screen, ... and watch this. We compute the left side, and boom, they match perfectly. It's so satisfying to see it work. We can even visualize it. Imagine 2 bars representing each side of the equation. As we calculate, you can see them grow to the exact same height, but what happens with huge numbers? Things get crazy fast. If we tried to calculate something like 100 choose 50, the number is astronomical. It's a 1 followed by 29 zeros. That's more than the number of grains of sand on all the beaches on Earth. It just shows the incredible scale of mathematics.
Thanks for watching.
And don't forget to subscribe for more fun with numbers. Have you ever wondered what infinity actually looks like? Let's explore it with a simple pattern. Imagine a rule where if you put in the number 1, you get 17. If you put in 3, you get 97. See the connection? Let's try a few more. If we input the number 2, we get 57. If we input 5, we get 177. Now let's plot these points on a graph. You can see they form a perfectly straight line. And here's the amazing part. This line goes on forever. We can plug in any number. No matter how huge 1,000, 1,000,000, 1,000,000,000 and, we'll always get a corresponding point on this line. It never stops, never bends, and never breaks. That's a little glimpse into the beautiful, endless nature of infinity. Thanks for watching. And don't forget to subscribe for more cool math concepts. Have you ever heard of the square triangular number theorem? It sounds complicated, but it hides a beautiful secret. Let's look at one part of it. Take any triangular number, like the ones made by stacking balls. The formula for these is a times a plus 1, all divided by 2. Now, what happens if we multiply a triangular number by 8 and then add 1? Let's call the result C. The equation looks a bit messy at first. C equals 8 times a plus 1 over 2 plus 1. But watch what happens when we rearrange these pieces. The 8 and the 2 simplify to 4. So now, C equals 4a squared plus 4a plus 1. Does that look familiar? It's a perfect square. It simplifies perfectly into 2a plus 1, all squared. So, any number created this way is always a perfect square. For example, if we let it be 3, the triangular number is 6. 8 times 6 plus 1 is 49 in our formula. 2 times 3 plus 1 squared is 7 squared, which is also 49. It's a perfect match. Math truly is magical. Have you ever seen numbers that act like a family tree? Let's check this out. We have a variable a. On one path, a leads to 2, a plus 2, which then points to a new variable, c. But there's a second path. A plus 1 foot leads to 2a, which then points to c plus 1. It's like two branches of a family leading to related outcomes. So how are these numbers actually connected? This is where the magic happens. The secret lies in a cool property of binomial coefficients. If you take the ratio of two specific consecutive terms, it simplifies in a really clean way. The ratio of 2n plus 1 to 2n, choose n, is exactly 4n plus 2 feet divided by n plus 1. By applying this rule to our family tree, we can derive the precise formula for c. It's all connected. Thanks for watching, and don't forget to subscribe for more math shorts. Have you ever seen this incredible pyramid of numbers? This is Pascal's triangle, and it's hiding some amazing secrets. Each number you see is what mathematicians call a binomial coefficient. And they pop up everywhere from probability to computer science. But let's focus on something really cool. The numbers running right down the middle. These are the central binomial coefficients. See how we can highlight them, creating a spine down the triangle? As we move down, these numbers grow incredibly fast, much faster than the ones on the sides. This symmetrical growth isn't just beautiful. It represents a powerful mathematical identity that helps us understand combinations and patterns in the world around us. What other patterns can you spot? Let me know in the comments. Thanks for watching, and don't forget to subscribe for more math discoveries. Look at these two calculations. 50 choose 2 times 35 choose 12. And then 49 choose 3 times 36 choose 11. These pairs of numbers look completely unrelated, don't they? But here's the mind-blowing part. When you multiply them out, they both equal the exact same enormous number. How can these wildly different binomial coefficients multiply to the exact same result? It's not a coincidence. It's an infinite pattern hidden in math. This beautiful piece of numerical symmetry was recently highlighted in the world of recreational math. With credit to Neel Somani and Matt Parker for bringing it to light, turns out this isn't a one-off trick. It's just a single example from an endless family of similar equations. It shows that even in a field as old as mathematics, there are still incredible, undiscovered patterns waiting for us. Isn't that amazing? If you love cool math facts like this, be sure to follow for more. Hey math lovers, let's dive into a fun combinatorics problem that often trips people up. Imagine you have a large group of 100 students. Two of them, let's call them Alice and Bob, have a special condition. They must either be chosen together for a project or not at all. We need to form a team of 50 students from this group of 100. How many ways can we do this? Let's look at two possibilities. The first one is to bundle Alice and Bob together as a single unit. So now we're choosing from 98 other students in this one Alice and Bob unit. To get a total of 50 people, we need to choose 48 more from the remaining 98 students. That gives us 98 choose 48 ways. The second possibility is that neither Alice nor Bob is chosen. In this case, we have to pick all 50 members from the 98 other students. This gives us 98 choose 50 ways. The total number of ways is the sum of these two cases. In using a cool combinatorics identity, this sum is exactly equal to 99 choose 50. So, if you see a problem like this, remember to break it down into cases. It makes all the difference. Thanks for watching. Have you ever seen an equation that just looks wrong, but is actually true? Take a look at this. On the left, we have 4 choose 2 times 8 choose 4 times 98 choose 49, and somehow that equals 6 choose 3 times 8 choose 4 times 100 choose 50. It looks like a bizarre coincidence, right? The numbers seem totally random, but this isn't a coincidence at all. It's a beautiful example of a deep mathematical identity. The n choose k notation represents combinations, a fundamental concept in probability and statistics. And while you could try to multiply these gigantic numbers out to check, there's a much more elegant way to prove it. This specific case is just one example of a more general, stunning formula. Want to see the proof and understand the magic behind it? Let me know in the comments, and don't forget to subscribe for more math mysteries. Thanks for watching.